Yes. So the first thing is we are starting with masking. For that you need to like build a simple circuit. Okay. So simple. First we will like go through the definition. So after that you can create a or build a blocks. Okay. So now take down the definition of masking. So here the masking refers into like yes masking lets you customize a subsystem's appearance and parameters, okay, like add user settings, okay, comma, hide internal complexity, okay, and to give it clean interface. So this is a definition of masking. Okay, so let us see what is the actual masking is in the Simulink. Okay, first you need to open the new blank model. Okay, so first we will build a simple blocks using like gain blocks, using the constant blocks and all. Okay, just one input and for the output, that's all. Okay, so first we will take the input block, that is sources. Go to the sources, take the constant block, place it here. Okay, then yes, take gain blocks, so it will be in the math operations. So we need a gain block here. Okay, so then we need a sum block, so take the sum block here. Yes, so these are the blocks we required for this interface. So also you can take display. So display here, it will be in the inside the sinks. Go to the sinks, take display, place it here. Okay, so these are the components we require for this interface. Okay, so now like we need to connect the blocks. So connect the constant block to the gain block, then gain block to the like sum block output will be connected to the display. Okay, here we will add one value. So for that again we take the constant block, just right click here, drag the block, it will copy the same blocks. Okay, so change the value into like 5 or anything. Here we will give the value as like 4. Okay, gain you can give it as 2, like this. Okay, so connect this sum block to 5. So here what happens, 4 to 8 means, okay, 4 to the 8 plus 5, here it will show as 30. Okay, let us see. So this is a simple circuit. Okay, yes, we got the answer as 13. So now we need to convert this circuit into subsystem. So after that you can make the masking for that subsystem. Okay, so how to do that means, so here first of all you need to select particular blocks like this. So we will select like this. So we will make subsystem based on these blocks. Okay, these all blocks will be inside the subsystem. For that first you need to select these select all the blocks and go to the edge here at the down side, click on create subsystem. Okay, yes, so here we have created one subsystem. Okay, so after subsystem we need to do the masking. Okay, what the masking means, so when you double click here means it should ask some values for this box and this one for this one or anything. Okay, so it should not show directly this circuit, it should directly show the values of these blocks. Just you can edit that value, and here it will be replaced. Okay, for that what you should do means, that is called as masking. Okay, so select this block, right click. So for like when you go into subsystem, for going back, you need to click here. Okay, here at the left top side, click on untitled. So here we got this circuit. Okay, so this is a whole circuit. Yes, so double click on this subsystem. So here you will find the circuit. Okay, go back, right click, there will be multiple options here. Go to the mask. Here there is a option called mask. Click on create mask. Yes, we got the window here like this. So here you need to go to the parameters dialog. So after that, here we need to add one. There are multiple blocks. Okay, like constant blocks. We have used 2 constant blocks, 1 gain block. There are total 3 blocks. You can take 3 blocks also, or else you can take any blocks. Okay, here we will take all 3 blocks. Okay, click on promote. So here we got one option here. Okay, so here you need to yes, go to the promote parameters here, then select the blocks which you need. Okay, so there is constant block, constant 1 block, gain block. Okay, so you can select anything. So first I will select the gain block, and here also select the gain block, put it to the promoted parameters here. Okay, click on OK. Yes, then we got the options here, gain block. So here we need to change it as so here you can change it as gain, and here give the variable. So I will give as m. Gain block variable will be m. So you need to change the value m, then the gain value will be changed. So after that we need to add one more box, that is constant blocks. Okay, there are 2 constant block. You can change anything. Okay, so here we will add value 1. So here I will give the data as n. Okay, next again edit. So we will get one more block here. Here put value 2, and here you can put p or anything. Okay, value. So this one is gain block, this one is the constant block 1. Okay, constant block 2. So these are the 3 settings you should do inside the mask. Okay, m is gain, n is constant 1, p is constant 2 block. Then click on apply, then click on OK. Okay, done. So here when you double click in this subsystem, it will show 3 parameters. One is gain, value 1, value 2. Okay, so for the circuit, so you need to check the circuit, whether what is the circuit and all. Click here, look inside mask. Okay, so here you need to change this value to the we have changed m, n, p. Okay, so this one gain block, make it as m. Okay, here it is select the default m. Then in the constant block change it to n. Click on OK. This one is p, so change it to p. OK. Okay, so this one is m, this one is n, and p. So if you change these 3 values inside the on the directly on the mask, it will change inside. Okay, internally it will be changed. Now we will run the simulation. Okay, so what is the gain value? Gain value is 2, value 1 we will give 2, value 2 we will give it as 4. Let us check the answer. So just click on the run button. Okay, so the answer is 8. Okay, so here the gain value 1 and value 2. So I will show the circuit here. This is a value 1. Okay, value 1, this one is a value 2. Okay, this one is the gain block, m value, n value, p value. You can directly give these three blocks values here only directly. Okay, when you double click your subsystem, it will show three values. One is gain, value, value 2. This is called as masking. Okay, no need to go into that circuit and you need to change here. Okay, that is avoided here. Okay, so like without masking, you need to go to this block and you should give the like some values, whatever it is. Okay, but when you put the masking means you can directly give the values from here also. Okay, you can change the gain value, you can change the constant block 1 value, 2 value, anything. Okay, so now for these parameters the output is 8. Okay, so I will change the parameters, like again I will change it to 10, value 1 I will change it to 5. Okay, value 2 I will change it to 8. Okay, let us see the output here now. Click on the run option. Yes, we got the answer as 58. Okay, like this you can make the masking to the subsystem. So always you should need a subsystem for masking. Without subsystem it is not able to, you cannot mask the blocks. Always first you should do subsystem and then you should do masking. What's the purpose of subsystem means? So you will reduce the overall design of the model. Okay, so reducing the design is one point, and another one point is reducing the complexity. Okay, so model will be visible, like visibility will be easy and you can understand easily, and there is no much connections and not much blocks inside a single sheet. Okay, so here there are only two blocks. There is no addition block, there is no constant block, gain block, anything. Okay, so this makes it simplified. And also here you can see in the definition, like add user settings. So you can double click here and you can change the settings. Okay, and hide internal complexity. So like internal blocks will be like this. You can build anything. Okay, so here this is a simple circuit, you can build it to any level. Next, give it a clean interface. So now here you can see there is one block for the operation and there is one block for the output display purpose. Okay, so like this you can do the masking for different applications. So now like we will design one more circuit. Okay, so it will be like more complex compared to this one. Okay, so let us design it. So I'll just keep it here. So now we'll start the blocks. Take the constant blocks, or else you can take anything. Okay, so you can take sine waves. So we'll design some circuit based on the inputs, sine waves. Okay, and constant blocks. So these are available in the sources. They are available, you can take it. So then sinks, you can take scope, or else you can take display, whatever you need. Okay, then go to the math operation. So there will be addition blocks. Okay, subtraction, gain block, whatever. So all the things will be there, so you can take any one. So let us design some complex circuit. Okay, so here I have taken the constant block. Again copy the constant block, connect these two to the add block here. After that we will change this block. Okay, so we'll give the values, different values to this. Next, again go to the library, take the multiplication block. Okay, so here there is a division, there is a dot, gain. Okay, there are multiple. So here we have product, take the product, place it here. Okay, na? So after this we will take one more constant block, keep it here. So here I will give the value as a variable, this is b. Okay, then this is c. Okay, so we'll first add the a plus b value, and we will a plus b into c. Okay, into c. So after into c, we need to divide it by 2. Let us put the division block here. Take the division block. Okay. So we'll divide it by 2, give the constant block value as 2 and click on OK. Connect the 2 here and one more here. Okay, so this is the actual circuit. So after dividing, you can give it to the display module, output display modules. Okay, and also you can add the sine waves also here. So it can be like you can design one more circuit here, or else you can just put it add it to the same like same circuit. Both are correct. Okay, so here we will design it to two circuits. So here we have done a plus b into c divided by 2. This is the actual equation. So I will also write this equation: a plus b into c divided by 2. This equation we have solved here is equal to y1. Y1 is nothing but like output. So this one display y1. Yes. So now we will give the make it as a subsystem. After that we will like directly we will mask these blocks, that is a b c. These 3 values we will give it in the masking. Okay, or else you can add one more yes, we will add one more thing here. So let us extend this equation to divided by 2. Sorry. So after divided by 2, let us again multiply with or plus. Okay, so we will subtract. Okay, subtract d into 2. So let us increase this equation. So for subtraction, we need to take the subtract block. So it will be available in the math operations. Go to this, take the subtract block here. We need a D block. Okay, so take the D blocks. This one we need to change it as D, and here D into 2, I think. So sorry. So here we need to add the gain block. Okay, D into 2. Gain will be 2 and subtracted. Yes, here we need to give this subtract to the division. Here divided by 2. Okay, so this output will be subtracted by the D square. So then we will give it to the output side. Okay, so this complete block will be like a subsystem. So this we will make it later. Okay, so now try this equation. So after this, you need to select that certain area. Okay, so we will select like this part. Okay, so just click on create subsystem. We got only one block here. Okay, so when you go to the subsystem, there will be a multiple blocks here like this. So after making the subsystem, right click, go to the mask, click on create mask. Here you need to select the parameters and dialogues. Okay, so then here you need to click on promote. So So after clicking on promote, go to the like promoted parameters here. So here you will find all the blocks which you have used in the like subsystem. Okay, you can select any blocks here. So one more time, let us see whatever the blocks we have used in the subsystem. So we have used constant 1, constant 2, and constant 4 will be D. Okay, 3 is 2. Constant is A, constant 1 is B, constant 2 is C, constant 4 is D. Okay, these are the 4 blocks we are giving the like in this masking. Okay, yes, first one is constant block. Select the constant block, add it. Okay, so here we will change it later. Okay, click on OK and open the window. So here we have selected the constant value. Okay, so I will make it as so here we will give it as A or value 1 or else A. Okay, so we will give it A, prompt A, value is also A. Okay, so then we will click on edit. Then here we will give B and B. Edit. Again we need to add C. Here also C. Then D. Here also D. Okay. So now we have finished the 4 blocks. We can click on apply and click on OK. Okay, so now when you double click on this subsystem, it will ask A value, B value, C value, D value. Okay, all these values. So then when you open this, here there is a variable A, B, C and D. These are the 4 blocks we are giving the values now. Okay, come back. Here we can find the subsystem. Give the A. Now we will give the A value. So A value I will give it as 23, B value 40, C value 2, D value I will give it as 4. Okay, so these are the values I am giving now. Click on OK. Okay, so let us run this simulation. We will check the answers. Yes, so answer we got minus 57. Okay, so here you can check here. So after all these operations we got the value as minus 57. So we will just change these values and after that we will check it. Okay, so A value we will change it to 230. Apply. Okay, run the simulation. So now we got like minus 264 like that. Okay, so directly you can change the values here and you can vary the output. So you can give any such values and you can check it. Sorry. Yes, we got the positive value. So you can give the values like this. D value I have given 450, C value 22, B value 10, A value is 2. Okay, so this value will be replaced in the blocks here. Here this block will be replaced with the A value, this block will replace with the B value, this one replaced with the C value, this one is replaced with the D value. Okay, like that. This is called as masking. Okay, so like you have understood the masking topic. So this one is the first circuit. So here we have made simple operations, and this one is the second example. Here a little bit more complex. Okay, so we got the same. You can design like multiple blocks like this. Okay, so after this concept, there is a topic called like MUX DEMUX. Okay, so we'll go to that topic. So if you have any doubts in this topic, you can ask, or else we will move to the next topic. Yes, so now we will work on MUX and DEMUX. So that will be under the signal routings. Go to the signal routings. There will be two blocks called DEMUX and MUX. These are the two blocks. So what they will do means, so mainly the main purpose of and when you double click here, you can select the number of outputs. Okay, so here you can make it, set it for 4 or 5, 6, anything. So if you make 4 means it will show 4 outputs here. Okay, like that. So you can change like this. So this is the DEMUX and this is the MUX. So first we will start with the MUX. Okay, so what is the meaning of MUX means? It will combine multiple signals into one signal. Okay, so here input side there will be a multiple signals, but in the output side there is only one signal. Okay, that's why it is called as MUX. Okay, combines multiple signals into one signal, that is called as MUX. So what are the DEMUX means? So here it will split one signal into multiple outputs. So here it got one input but multiple output. You can change it to output to any value, just 6, 8, 10 or anything. So you can change it like this. You can increase the size here. Okay, so like this you can increase the number of signals. Okay, so here total it got 6 output pins. You can connect 6 signals here on the output side. Okay, like this. So here this is the DEMUX. Sorry, this one is as DEMUX. This is a MUX. Okay. So and you can change the inputs, number of inputs or number of outputs, anything. So we will execute this example. Okay. So using the MUX. First we will take 3 inputs. Okay, number of inputs 3. Okay, so it will be sent it as one signal. Okay, so now you can increase the size like this. So we will use this after later. First we will do with the MUX. So what will the MUX do? It will combine multiple signal into one signal line. Okay, so this is the definition of MUX. Yes, so here we will combine multiple signals. Let us go to the sources. Here you will find multiple input signals, whatever, you can take anything. Okay, so here there is a sine wave here, and here there is a step wave. Yes, so here we have ramp. Yes, so these are the 3 different signals. So this is a sine wave, this is a step wave, this is a ramp wave, signal. Okay, so connect these 3 signals to the MUX. Okay, so now we have connected these 3 signals to the MUX. So after this, just you can like use a scope, okay, to plot the graph. Go to the library, go to sinks, take the scope block, connect the scope block towards output here. Okay, so now what happens, all these three signals will be plotted in a single graph. Let us see. So after running, open the scope by double clicking on that. Yes, so here we got the graph. So here you can see all the signals are like they are replaced with each other. Okay, overwritten. So first this is a sine wave, this is a step wave, this is a ramp wave, ramp signal, like this. Okay, so those are based on the amplitude. Okay, so here the amplitude is like 1 for the sine wave and the step wave, but the ramp wave goes on increasing in the slant, like this is called as ramp signal. Okay, so now we need to divide three signals. So for that we need to use DEMUX. Yes, we will use DEMUX. And here we have used three signals, so output signal should be 3. So let us connect this one here. This one is a MUX, this one is a DEMUX. So then we will increase the scope inputs to the 3 inputs, means just double click on the scope, go to the settings. Okay, so in the settings there will be a inputs number of axes. So here you need to change it to 3. Go to the settings, change the number of axes to the 3. Click on OK. So here there will be a 3 plots. So where the graphs are plotted different graphs. Okay, close this one. So here we got 3 inputs for the scope. So you can increase the scope size like this. Okay, yes. So how to give 3 inputs for the scope means just double click on the scope. Okay, then go to the settings, go to settings here, go to settings here, number of axes, change it to 3, click on OK. So after that you will find 3 graphs here and 3 inputs here. Connect these 3 inputs to the DEMUX. Yes, here now we have combined these 3 signals into a single line. Okay, then using DEMUX we have extracted 3 signals from a single line. Okay, so this is the explanation for MUX, and then there is a DEMUX. What it will do means, so mainly DEMUX splits one signal into multiple outputs. Okay, yes. So let us run the simulation. Yes. Now click on the scope. Yes, so here you will find different signals in the different plots. Just click here. So now you can see here the step wave, so it will be like this. The sine wave, it will be like this. The ramp wave, like this. And you can change the color or width of the line here. Okay, so how to change it means, go to the settings here. Okay, so settings, go to the styles. Yes, go to the slides. here line option, so increase this width, so you can increase it to 2. Okay, yes, so we got the width change here. Okay, so increase the width to 4, let us say 4, click on apply. So here it is increasing. Okay, and also you can use the marker like this. So there are multiple options here, you can use whatever you need. Okay, and plus, okay, like this, like basic we will don't need anything. Okay, so after that here, so it's style. Okay, so here we can change all the lines design. So design also we can change it to dotted line like this. Okay, or else you can change it to like dot 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 lines like this. Okay, and like this, there are multiple designs, you can set it to anything. So we'll take the straight lines first. So background color you can select anything. Okay, so you can change it to any color you need. Okay, so black, blue, or anything. Okay, so we'll choose like this, we'll keep it like this, it will be nice. Okay, then you can change the axis color to whatever you require, like, okay, this axis color. Okay, okay, so these are better. Also you can change the line color also like this. Okay, this one is better. Okay, so now you can see this is a sine wave, this is a step wave, this is a ramp wave. Okay, and also you can change the names. Okay, so we got separate markings for the different plots. Okay, okay, so this is all about the plotting graph. We got 3 graphs in a different like plots. Okay, like this you can use the DEMUX and MUX. You can like include signals like this, you can include the values, you can even include the operations, anything can be included using the DEMUX and MUX. Okay, so without DEMUX you can directly give it to the scope, but what happens, all the 3 signals will be like mixed in a single graph. Okay, to avoid that we will use DEMUX. Okay, this is a DEMUX, this is a MUX. Okay, so now there is the same concept, the same blocks, but some additional features that is called as bus selector and bus creator. Okay, those are also same do the same operations compared to MUX and DEMUX. Here you can find bus creator and bus selector. These are also used for the same purpose, but here what is the advantage means I will show you. Okay, so we have taken 2 blocks here. So yes, so this is a bus creator. Okay, so this one is a bus selector, and here this is a bus creator. Okay, yes, so like what is the purpose of these two when it compared to the MUX and DEMUX means? So here you can select the particular signal. Okay, So you can select the sine wave and leave the step wave, okay, or else you can select the step wave and leave both sine wave and ramp wave. That is available in the bus selector and bus creator, okay. So I will show this simple example. So take the same three signals again here, connect these three signals to the bus creator. Yes, so here we will take it as 3, number of inputs should be 3, okay. So connect these three to the sine wave, step wave and the ramp wave, okay. So here like I don't need step and ramp, I need only sine wave, okay. So double click on this block. So here you need to select only one, okay, signal in the bus, signal 1, signal 2 or else anything, okay. You can select one signal and click on add. So then we will take the scope block. Scope block will make the signals, input signals as 1, okay. So we'll connect this scope to this bus selector, okay. So first we'll name the line sine, this is step, this is ramp, okay. So now we got the signals sine, step, ramp, okay. Click on OK here. So then click on run option. Yes, so here it is not possible for the signals, okay. You can use it for like constant blocks, variables like that, okay. So here the buses are mainly used for the like different operations, not for these operations. You can use the constant blocks and all, okay. So simple, what is the difference between bus creator and bus selector means? So here in the bus selector you can select particular signals and you can obtain the output here, okay. So if you have three signals, input signals means you can select any one signal and you can give it to the output, okay. So that options is available in the bus selector, okay. So bus creator will like take the multiple values from the like you can use it for motors, okay, for the torque, speed, voltage, current values, okay. And also you can use it for batteries. So batteries, in the battery also there will be a voltage, current value, SOC, okay, like the parameters you can obtain it in the output side, okay. For that purpose we use these blocks, okay. So now we have completed topics about the DEMUX, MUX, bus selector, bus creator, okay. You can check it for battery, okay. So or else I will show you in a minute. So go to the Simulink library. So here in the Simscape library there will be a Sim Power Systems, Specialized Technologies, Fundamentals, control measures, fundamental levels, solar. battery here. Go to the SIMscape. So inside the SIMscape there will be a SIM power systems. So inside the SIM power systems there will be a specialized technologies. Go to the electric drives. So inside that electric drives there will be extra sources. So inside extra sources there will be a battery module. Okay, so here you can use the bus selector. Okay, okay. Like that. So here we have taken the M terminal is nothing but a measurement terminal. Okay, so you can collect it to the bus selector. So here you have three values: state of charge, current, and voltage from the battery side. Okay, you can take any one. So here delete these two signals, and you can add new signals from the batteries. Battery, there will be SOC, state of charge, what's the battery percentage and all details. Then current, you can select the current value, then you can select the voltage value like this. Okay, you can select three values and click on OK. So after this, you can connect it to the scope block, and you can check the values. Current value is state of charge and the voltage. Okay, yes. So when you are using these blocks, means you should use a like one more block called power GUI blocks. Yes, so here you can search directly here. You can search for power GUI. Okay, power GUI. So you will find the blocks. So after that you can use it. Okay, search for power GUI. So it will take some time. Okay, so just you can search here on. Yes, so you can directly search for Power GUI, so you'll find this block. Yes, so after this block you can click on the run option. So the simulation will start to run. So after that you can find the these three values inside the scope. Yes, so here you can see all the three values. One is state of charge, okay, so it is 100, current is 0, voltage is 1.5. You can vary these values. Just double click on the battery, you can give the values here. Okay, so let us say voltage I will give it as 12, state of charge you can change it anything. So current no need to change, so based on the load it will show. Okay, so here you can select the particular battery, lithium ion, nickel, okay, nickel metal hybrid, anything. Okay, so click on OK. So now we will start this simulation. Yes, so now here you can see the scope value. Yes, so the current is 0, here the voltage is 2.3 something, SOC is 100. Okay, like this you can use the bus selector. This is a bus selector. Okay, okay, so yes, so after this we have the next topic, so there will be multiple converters, when it comes to the DC to DC converter, AC to DC converters. Okay, so there are multiple converters, and also you can solve the mathematical operations, logical operations. Okay, or else you can solve the laws, Ohm's law, okay, Faraday's law. These formulas we can solve it through the blocks. Okay, I will show simple Ohm's law. Okay, so Ohm's law, there will be a current, voltage and resistor. Okay, so you will multiply the the basic formula. Okay, V is equal to I into R. Okay, you will multiply current and resistors to get the voltage. Okay, so for that you get let us build a simple block to calculate the Ohm's law. Okay, first we will take the constant block. Okay, so then we will take the multiplication block. So product, here it is a product. Then we need a display. Okay, so go to the things, take this display. Okay, so we have two values, we need two values. One is current, okay, and one is resistor. So if you are if you are finding the R value means, then you can write R value means I into V. Okay, like that. So you are finding means finding the I means you can write it as I is equal to V by R. Okay, like that. So now we are finding V. Okay, V is equal to I into R. So this is a voltage. This one is a voltage. Okay, sorry, voltage. This one is current, and this one is resistor. Resistance. Done. So current value I will give it as 2 amps. Resistance value I will give as 10 ohms or 100 ohms. Okay, so then we'll multiply both these current and resistor, and we will give it to the display. Okay, this is a Ohm's law, simple Ohm's law. So just you can create a box, and here you can go to the settings, and here you can select this last option, create area. Okay, it will create certain area. Here you can name it as whatever you need. So Ohm's law, I am solving Ohm's law. Okay. Okay, so like this. So when you click on run option means, so these are all other applications. Okay, so this one is different, this one is different, and this one is different. You can mark like this. Okay, so this one is different circuit, this one is different, this one is different. Okay, so here we got the voltage of 200. Okay, current into resistor, I into R is equal to V. Okay, then you can change this, you can find the for example, you need to find the resistance value. Okay, so resistance, for the resistance value you need to write V by I. Okay, so this will becomes voltage. So this will become voltage, this will become current, this will become resistance. Okay, so here you need to you no need to use the product, you need to use division. Go to the library, go to the math operations, take the division block, divide, place it here. Okay, place it here. Okay, okay, done. Voltage, let us say voltage is 230 volts, current is 10. Okay, then we will calculate the resistance value. Okay, so let us click on the run option, you will get the resistance value. Okay, so here we got the resistance value of 23 ohms. Like this you can solve multiple laws. Okay, you can try it for different laws. Okay, so just I am showing Ohm's law, you can try it for multiple operations. So this one we are going to do in the upcoming classes, but here for the just example purpose we will show you battery connection. Okay, so this one we are going to do it in the next upcoming classes. So I will explain all these all blocks. Okay, when you are using similar to this block, you need to use Power GUI, so which will support these connections and all. Without Power GUI you cannot execute these blocks. Okay, so these are simple blocks, you can execute without any blocks and all. Okay, so now we have completed with these MUX, DEMUX and bus selector, bus creator. Okay, so on some of the calculations related to the formulas, Ohm's law, Kirchhoff current law, voltage law. So all these formulas you can try it in the Simulink library. Okay, so after this save the file. So you should save it in the desktop folder. So go to the desktop. So in the desktop you have saved the MATLAB Simulink files. Double click on that. So here you can name it as basic equations. Okay, or else first we have done DEMUX, MUX. Okay, MUX, DEMUX and bus selector. Okay, like you can name it as anything, bus selector. Okay, done. So these are all the examples you can run it in the Simulink. Okay, so after this class I will share some questions, assignment questions in the Google Classroom. Okay, try it for yourself. Okay, done.